Hello good people, I'm going to look at this trigonometry problem. As always, I suggest you pause the video and attempt solving the problem yourself first. Alright, let's have a look at this. Seeing how this is a trigonometry problem, a drawing is always nice. So here's one I prepared earlier. I know, you are all very impressed. Okay, now let's deconstruct this problem a little bit. So we have a hot air balloon and we have a UFO. What is the information given to us? And what is it that we need to find? Okay, so I'm told that the balloon is flying 195 meters above the ground. So I'm also going to indicate that on my diagram. So 195 is this distance here, and I'm going to label it. We are also told that the direct distance between the balloon and the UFO is 905 meters. So we are talking about this distance here in orange. That is 905 meters. The question is asking about the altitude of the flying saucer. So we are looking at this distance or this altitude here in red. That is what I need to find. That is my unknown. The question also states that the angle between the level flight path of the balloon and the direct distance to the UFO is 37.5 degrees. So what do these things mean? What is this level flight path? Well, that is an imaginary horizontal line that runs parallel to the ground, and it is at the same height as the balloon. So I'm going to draw that in yellow. So this is the level flight path of the balloon. The angle between the level flight path, the yellow line, and the direct distance to the UFO, the orange line, is 37.5 degrees. Alright, and now I have a right angle triangle, the one that is formed by the orange, yellow and red lines. I need to calculate the value for x. However, x is made up of two sections. It is made up of the green section, if you like, that is the altitude of the balloon, so this section here, and it is also made up of this blue section here, the distance between the horizontal flight path of the balloon and the UFO. The green section will be 195 meters. That is the altitude of the balloon. What about the blue section? Well, trigonometry to the rescue. This is a right angle triangle, which means I can use one of the trigonometric functions. I'm going to write SOHCAHTOA just so that I have all of my options in view. The next step is to label the sides of my right angle triangle with respect to the angle given. So with respect to this 37.5 degrees, the blue line, well, that is the opposite. The orange line, that is the hypotenuse, which means the yellow line is the adjacent. I need to calculate the value for the opposite, and I have been given the hypotenuse. This means that I need to use the trigonometric function that uses the hypotenuse and the opposite, and that is sine. As always, I'm going to write out the general formula for sine. So sine theta equals opposite over hypotenuse. In this case, I have sine of 37.5 degrees equals opposite, which for now I'm going to label as y, over the hypotenuse, which is 905 meters. I need to rearrange this equation to make y the subject. This means transposing 905 meters, and I will do that by multiplying both sides by 905 meters. And that will give me 905 meters multiplied by sine of 37.5 degrees equals y. Calculator to the rescue, 905 multiplied by sine 37.5. And I get 550.929. So it's 550.929 meters equals y. Considering that both of my measured quantities have three significant figures, I'm going to round my result to three significant figures as well, and that will give me 551 meters. Recall that this value, 551 meters, represents the blue section on my diagram. The question is asking me about the red section, or the red line, the altitude of the UFO. Well, the red line is the green line plus the blue line. So I'm simply going to add those two numbers together. I have 551 meters plus 195 meters. And that will give me 746 meters. So at the end I can say that the flying saucer is flying at an altitude of 746 meters. That is all for now, and I will see you on the flip side.